Hi everybody, Tim Hughes here. I'm co-founder of Digital Leadership Associates. I'm also the co-author of the book Social Selling: Techniques to Influence Buyers and Changemakers. I've got with me two people today, Stephen and Katie. What I'll do is I'll get you to introduce yourselves. So Stephen, why don't you go ahead and introduce yourself, say where people can get hold of you.
Okay, very good. Hello, thank you for coming. My name is Steven Struhl, and I am the founder of convergeanalytic.com with no S on the end, just Converge Analytic. And you can reach me at convergeanalytic.com. I'm the author of the book we're talking about today. Hope you can all see it.
Artificial Intelligence Marketing Predicting Consumer Choice.
Right, very good. That's what we'll be discussing.
So you're Stephen with a V, aren't you? And your surname
is
Truhl.
Yes, that's correct.
Cool.
Very good.
Katie.
And Katie.
Thanks, Tim. Yeah, I'm Katie King. I'm Director of Transformation at Digital Leadership Associates. You can find me at Katie at social-experts.net and also on Twitter, Katie at Katie E. King, and on LinkedIn. So yeah, look forward to sharing some more insights with you shortly.
So today it's all about your book, Stephen, about artificial intelligence and consumers. Katie, do you want to kick off with a first question?
Absolutely. Yes, Stephen, I want to keep it quite broad to start with. We're reading a lot of statistics every day, and saw some fascinating ones recently from PwC talking about GDP could be around 10% higher by 2030 as a result of AI. So I wondered if, despite all the scaremongering that we're reading, hearing about daily in all kinds of business and vertical industry and national papers, whether you actually think that we'll see job gains and, you know, a boost to real wages as a result of AI?
Well, that's a very interesting, of course, very interesting question. And my sense is that it is going to cause disruptions, and whether it causes job gains or not is actually more of a social question than the question of what computers can do and what computers can't do. Because it will be a disruptive process. People will be displaced, and then the question of whether they get, shall we say, replaced into or placed again into another occupation, or if occupations expand, I think is really a question of social policy. And you know, as far as that goes, you know, here in the States, I'm not that optimistic. Perhaps in other places that will be taking the lead, that will happen. But certainly the machine are going to do more work that can be easily done in a series of very complex steps that are repeated, and they could do more work that requires a lot of memory. So the question is, are we going to move to more judgment-based jobs for people? And your guess is as good as mine, really.
Because when I grew up, we had typing pools.
Yeah.
So I used to write all my letters out by hand. I know this may shock some people. There wasn't computers or word processors. We wrote our letters out by hand, and we handed them to a team of people who typed them up. And I know when I quite often see on LinkedIn, what's going to happen to the jobs? And I say, yeah, but what happened to all the people that were in the typing pools? And they go, what typing pools? What's that? You know, we don't even remember what they are. And those people went on and got other things and did other things, and you know, life was reborn, and we moved on, and we don't even remember that disruption that the first early word processors came about and gave us.
You're right. A lot of jobs have disappeared. There's just an interesting article about that this week. You know, it's like, what's a phone operator who pulls the plugs and plugs them in again, which is a job that employed thousands. What's an elevator operator? So a lot of jobs have been displaced, and so far we've done a pretty good job of, if I can use the word job in the other context, we've done pretty well at finding other things for people to do. But it's a question of whether, you know, we're going to continue to have this kind of forward momentum. Your guess is as good as mine, really.
So we're seeing marketing getting far more complex and becoming far more technical. You know, there seems to be a requirement for every marketing department to get, you know, either a data scientist. You know, in your book, you've got all of your various models that you can download and use. And do you think that marketing needs to get more technical, or do you think technical or technicality should still sit with IT, you know, the CIO or the CTO or something like that? I mean, where do you think it fits nowadays?
No, this is an easy one for me. I am a firm believer that, if we're doing what's called marketing science, or has some various other names that are similar to that, it belongs with marketing. I think,
right.
we have a big tendency to put people in silos and not to communicate. And this is, I think, one of the big shortcomings that I see in a lot of organizations that I deal with. They just don't integrate insights appropriately. And if they're marketing sciences people and they report to the CTO, they're all into machinery and the latest algorithms and this and that and the other thing, and they're not into really delivering things that help strategically with the company's direction, which is where marketing should be positioned. Although I did once work for a company that had a marketing and special promotions department, and they made things like these big stuffed dolls and also did marketing, so they were not clearly part of a corporate mission, but the stuffed dolls were nice.
But the lines are definitely blurring, Stephen, aren't they? The lines are blurring more than ever with the sales role, the customer service role, the HR role, that they're all touching upon, they're all using similar platforms to communicate with similar but different stakeholders. And, a marketeer might be buying a SaaS-based piece of software that traditionally the CIO or CTO may have been more involved with from a purchasing point of view. So I think they're all encroaching on one another's space and making it quite uncomfortable for one another. And when they don't collaborate, that's when I think the problems occur. But maybe we'll come back to that.
Okay.
So I think on that note, Stephen, it would be, do you believe that senior managers, boards of companies are needing to get these teams to collaborate much more? Are you seeing more of a trend for better, wider collaboration amongst the teams that we just outlined?
I wish there was more collaboration. I always wish for more. I go to work with a lot of end clients, and I find that sometimes we go to top management is surprised that the project has actually been taking place. And they actually, when did you guys start doing this? Did we know about this?
Yeah.
And I think the funniest one was recently with a large metropolitan transportation system. They they wanted to do something with non-riders, so they had to address their perceptions to try to get them to ride the system more. We went to the head of the board, and he says, "Why are you doing this? This is all imaginary. These aren't real. These people don't have any experience. They haven't ridden the train. How could they say anything about it?" So not informing and not collaborating, I think, are the downfalls of many very ambitious projects, and often stand in the way of achieving a true strategic objective. So what's better, and I don't know where the particular problem was, whether it was the people who didn't approach the executive or the executive who was unapproachable. But clearly they need to have more collaboration in that particular instance.
It's the silo mentality still, isn't it? I
think we've seen, Kate, haven't we, that there's this sort of still this thing of random acts of artificial intelligence or something where people go off and do their own thing.
Exactly.
Without actually telling anybody. And we've been trying to explain to people that there needs to be some element of well, not an element, but a strategy. And we've also done webinars where we've had people come on and they've talked about how artificial intelligence is kind of a bit like social. There's a bit in marketing, there's a bit in there's a bit in every single department.
Okay.
And with artificial intelligence, we actually kind of need to bring it all together. That what's in customer service, in sales, in marketing, and there needs to be an overall strategy.
Absolutely, and you're right, Tim. As we've witnessed with lots of companies, it is that tactical approach to it, or that panic of we must get on the bandwagon, we must do something, we must invest in some R&D, without really thinking about where it's heading and what business goal it might satisfy or how they can innovate with it. So
what do you think, Stephen? Do you agree with that? Or
yes, I think although again, artificial intelligence is not always exactly what people think, and that's one of the reasons I put the book together. We can talk about this a little bit later, but it's often a tool rather than an end in itself. We can get to that, but yes, it's often, things are often scattered throughout the organization. There's a lack of coherent approach. Everybody's saying something slightly different. Everybody's executing a little bit differently, and a lot of turf wars. Yeah. And it's very hard to resolve that. I've seen some organizations, in fact, once worked in one where they tried to resolve that by what's called matrix management. Are you familiar with that one, Katie?
Yes.
Yeah, it's an absolute nightmare, because when time comes to allocate rewards, people start fighting over who gets what because there's no clear lines of authority, and the idea is to get people to work together, but it seems like sometimes it's very counterproductive.
Agree. While we're talking, Stephen, about issues that certain companies have and how they adapt, you talk in the book some good examples, FMCG, cereals, that sort of area.
Mm-hmm.
What's your experience in applying what you're recommending in the book to maybe B2B, financial services, legal, that sort of area? Is it as applicable to those kinds of organizations and sectors?
Yeah, actually, one of the reasons I picked the examples I did was because they're sort of easy to, to understand. I mean, if you're talking about middleware or, a machine that makes dental equipment or something like that, you spend 3/4 of the time, or insurance policies, you spend 3/4 of the time explaining what you're talking about. What is this particular thing that you're trying to tell me is being changed. So there's a lot of technical language, a great deal of terminology that you would need to put. Again, it gets very complicated. Like certain financial services are very complex, and people who don't deal with them day to day tend to get swamped with the terminology. Same thing with software. Most people don't even know what something like middleware is or what a rack system is. So I would spend all my time explaining to people, what these things actually are. So one of the things about the book is I wanted to make it as accessible, or should we say, as little non-accessible as possible. So, everybody knows what cereal is. That's one of the reasons.
And do you have any business-to-business examples? I mean, in your own experience, do you have any business-to-business examples?
Yes, you do a great deal of business-to-business, and it's largely in things like software, hardware equipment, large industrial equipment, and so on. Those kinds of very technical areas, engineering types of applications. Occasionally, we'll get something in insurance, like optimizing insurance policy. A lot of work with pharma. Again, that's sort of hard to explain.
Yeah, I think you mentioned broking as well in the book, don't you? Examples in the broking space too.
Yeah, there's an example from brokerage in the book where we tried to understand what it was that got their customers to feel more loyal to them, if there's such a thing as loyalty to a brokerage. Although they felt there was. So, we at least found some questions that seemed to be closely aligned to using the service more.
And do you feel that that the children of today are being trained in data science at schools? Do you think that there's a grounding, or is that something that you suddenly realize at 18 or 19 when you're at college, that's what you want to be?
Well, I've only met a few people who actually knew that they were going into the field. They generally go into a specialized program. A lot of other people just sort of fall into it. It's. I don't think a lot of people want to be firemen when they're kids, or policemen, or go into Navy SEAL. I don't see a lot of young people saying, I want to grow up and be a data scientist. So it's just not very glamorous.
Yeah.
You know?
As we said earlier, as the jobs change and as the kind of robots, increasingly, encroach on our world, maybe they will need to be teaching new curricula in the schools and in the colleges and universities, because what they teach today may not be, fit for purpose.
Yeah, I think, what universities do is a sort of interesting question. I'm not at all familiar with what goes on your side of the ocean, but I do know that here, I have a lot of academic friends, and bringing them up from what was going on 20 years ago is a big challenge. In the actual field, they tend to be grounded in stuff that happened 20 or 30 years ago. And also, when you say, well, you're an academic, you're not practical, it's really a cliche, but it does seem to have, an element of truth to it, where what's a practical application? What would you actually get in the real world? Seems often to be sort of distant from the things that they're talking about. So, there are some good academics, but it's, in terms of doing things practically, but a lot of them are, again, you read the textbooks, they're way behind. They're talking about stuff that was maybe done in the 70s and has been superseded. And they're also talking about doing things, you read a paper and they're doing something which never would happen in a real world study. So, a little off the track, but, I was corresponding with a guy and he said, I figured out how to do segmentation. And he had 12 variables that were used as the basis for segmentation. That would never, ever happen in a real study. By the time people get their fingers over it, you have hundreds of questions being asked, and you're lucky if you can whittle it down to 40 that will get into the segmentation study. So I said, well, this may work, but does it scale up? And he didn't really know what I was talking about.
That brings us to the next relevant question to that, Steven, around the book. So tell us why you wrote it and who it's aimed at. Okay.
Well, of course, there's a lot of reasons for wanting to write a book, as I'm sure you know, Tim.
Yeah.
One of them was, I did just want to do something that was useful. And I know that's happening now because I'm using 2 copies to prop up my webcam. So it's useful. And, but, it just seemed that there was this gap. There was a gap, and I wanted it to sort of bridge different schools of thought. There's a big data science industry that's, sort of oriented toward digging into historical data, digging into transactions, finding people on more platforms, putting the platforms together, putting their phone together with what they're doing on the computer, with what they're watching on TV. You're trying to get this big picture of what's going on today. That's a huge industry, and it's very technically challenging. And then there's another approach, which is, I would say, more forward-looking. That's my bias, that it's more forward-looking. If you're looking at what people have done, you're looking at history. And history gets you to have a very good fix on what's going on today, or if you're not lucky, what was going on yesterday or the day before. And there's another approach where you actually propose things to people who are going to buy your product and get their responses to something new. And my thought is that the only way that your company survives long term is by coming up with a new thing. I once attended a great talk, and the guy said, "You have to be the company that puts yourself out of business." And that's a very, I think it was a great talk to great thought to hear him talk. You have to be the one who comes up with the innovation that's going to supplant what you have today. You don't want somebody else to do it and take your business away from you. And so I think there are these 2 streams. You want to do much better at understanding what your customers are doing today and wanting today. But there's also the more predictive stream, which is trying to understand what you can do next. What's the next step? What's the next thing? And I was hoping that we could sort of bridge these 2 in some way with the book. There are these 2 communities. They don't really seem to talk to each other too much. So I wanted to be a bridge. I also wanted to, get some people who are interested in the more historical method to understand that there are ways to look forward, and there are ways that you can do that, at least short-term forward, and actually get good predictions and get things that are actionable and useful. So that was part of the emphasis. And of course, another impetus was that, there's so much nonsense out there. There's so much stuff. There's so much smoke being, and to me, it's a little bit annoying that there is so much. So in a way, I wanted to say, well, this is really what I think. And, there's a lot of stuff out there that just doesn't pass the test. And I wanted to sort of try to winnow out some of the stuff that has passed and some of the stuff that hasn't passed. So a bunch of motivations for writing.
So Steven, in the book, you talk about artificial intelligence, machine learning, cognitive learning. What's the difference, and why should people care?
Well, even people at companies like Google don't seem to know the difference between artificial intelligence and machine learning. So I'm not sure. I think they overlap a lot. I don't know if they're exactly the same. And I think, in terms of, what's the semantics behind it? When people talk about artificial intelligence, they seem to think that it means this is something that's going to navigate the real world by itself. Okay, it's going to be out. It's going to be a self-driving car. It's going to be a robot that puts together a building. I just saw an amazing video where this robot arm put together a brick building and did it 3 times as fast as a worker.
Yeah.
That's that's a kind of artificial intelligence. You don't think of it, but it has to know, how to pick up a brick. It has to know how to lay it. It has to know how to do mortar. So there's a sort of intelligence behind that. But and I think machine learning is more strictly in the realm of the machine's living in data and it's learning something from the data. So it may not. I think if there's any distinction, machine learning doesn't have to navigate the physical world. That would be the only, but otherwise I think they're really very similar. Machine learning is a machine that learns from the data. We set it up, we may set it up to know, in other words, we may set it up to tell it how to learn, but it learns something from the data that we can't learn. I think one of the examples in the book that really fascinates me is this hierarchical Bayesian analysis that I talk about, where basically the machine's learning from repeatedly sampling the data, where there's missing data for, say, one observation. It samples other observations and it compares them to the one that it's sampling. How similar is it? And it makes an estimate. Then it does it again, it updates the estimate, updates, does it thousands of times for each parameter that it's trying to estimate. And it actually learns something from the data that we could never possibly hope to learn by ourselves. In other words, you could have a room full of mathematicians doing this for 1 million years and they would not get to what the machine gets to. So it actually learns what the parameter ought to be for that person. And when we compare it to a full experiment where the data is present, we're about 95% accurate. So it's learning something that we can't possibly learn. And that's machine learning. Cognitive learning, you got me. I don't know what the difference is between machine learning and cognitive learning. It's like, my younger son was talking about getting a job. He says, I don't know the difference between equipment and supplies. And he said, I don't think there is a difference. He said, well, are they both things that remain, that you need to constantly replenish? And, I said, yeah. He said, okay. But,
it's kind of the same.
Yeah. But he was thinking about, getting a job. And, he'd done a little internship in a hospital supply room, which is now called materials maintenance. And, what's the difference?
With quantum computing, will the computers learn to analyze the data, do you think?
Well, computers do a great job if you set them up to do the task. In other words, that's what they do. You set them up, you train them, and then they'll do a task. Will they learn how to train themselves? That I don't know. One of the things that's fascinating me is that computers can see things and data that we can't possibly hope to see on our own. but they don't have what we consider to be common sense, which even an animal can have. Look, like a dog can have common sense. But there's these things called Winograd schemas. I talked about them in a bit in the book. And this fellow Winograd came up with a bunch of sentences, and the computer can't get them right, and a 3-year-old can get them right. For example, the ball went through the table because it was made of steel. Okay, what was made of steel? The ball or the table? Well, the computer doesn't know. The computer can't figure that out. It's common sense. All right, but again, you say what's made of steel, ball or table? Computer gets it right 50% of the time. Just saving by chance. Or Jim couldn't see over Tom because he was shorter. Who was shorter, Jim or Tom?
But according to the latest, there was a fascinating program on the UK's BBC 4 program a couple of evenings ago, and it said that what's taken humans millennia to achieve, the robots have achieved in just a few decades. So what you're referring to there is that maybe more general artificial intelligence and that right. kind of sentience, and I think that will come, but it might not come for another maybe 40, 50 years.
Yeah, it's hard to say.
We're okay for in our lifetime, but I think that common sense and that edge and that compassion and that sentient nature that humans have is fine for now. But that when that gets replaced, then I think it's a game changer.
Right, and again, I don't know, when or how this is going to happen because, really. Decision making of any kind is affectively informed. And affect is an emotional response, and decisions actually are driven by emotion. We can cogitate on them, but it's emotion. And there was just a fascinating anecdote by this fellow Oliver Sacks. Are you familiar with him? He was a neurologist who wrote about all sorts of interesting brain problems. And, he saw this in patients. He wrote about one where the area in the brain that mediates emotion was destroyed by a tumor. And then the person could not make decisions, or he'd make terrible decisions, and he was indifferent to whether he made a good or bad decision. Yet he was cognitively completely intact. He had an IQ of, I think this guy talked about an IQ of 135. So he's no dummy. And he could do all sorts of abstract problems. But when it came to making a decision in the real world, he could not do it. And it was because the affect was driving him. Now, if it turns out that, navigating in, a reasonable way in the real world is driven by affect, I don't know how you get that into a machine. It may happen. It may be, we may be able to simulate it in some way. But even if we simulate it, is it going to be the same as affect? And of course, this is where we get into all these ethical concerns with machines that can navigate the world. Are they going to, in fact, understand ethical problems in the same way that we do? And who knows? If we actually can simulate those processes. But to me, these processes are rooted in not just neural circuitry, which is, by the way, nothing like computer circuitry. And this whole idea that we're simulating a brain in some way is purely fallacious. It's just the latest convenient metaphor to use to describe a brain. But if it's actually rooted in all these lower systems and the limbic areas and so on, who knows how that's ever going to be matched or simulated, except with a something like an anatomical creature. And
but the ethical problem is still an issue, given that what's ethical in one part of the part of the world now may be unethical in another. So I think even despite the kind of issue of programming that or not being able to program that into the robots, we've still got the fact that what one part of the world is doing with their research into AI is very, very different and perhaps quite frightening to another region.
Yes, it's true.
That's a big subject for another webinar maybe, but that's fascinating.
Right.
So, Stephen, you talk in the book about there's a lot of work in there around customer questionnaires that have been created by brands. And you talk in there about good and bad practice. Do you want to just briefly give us a summary of some of those and how you see that?
Okay, well, the good practices are always to understand the people that you're asking about, first of all, you asking the right people the questions, which is harder than it may seem. You know, it's very, very easy to grab a convenient sample or convenient swath of data and, you know, just go with that and not really get to the people that you need to talk to. And again, non-representative people can give you a lot of data, but not a lot of information. Data is just stuff. It's just things that you have. It's anything you can measure. Information is something that helps you make a better decision, helps you understand what to do in circumstances of uncertainty. What can you do? The other thing is to make sure that you are, you know, of course, you know, using the correct language. Are you actually talking to these people in a way they can understand? Are you exposing them to something that makes sense to them? I can't tell you how often this happens where, you know, the company has all these concerns, the organization has all these concerns, and they know all these things, and they just assume that everybody else knows all these things, particularly as it gets more technical. Although, you know, again, so all doctors, of course, understand what our product is about because we sell to doctors. You know, all surgeons understand the differences between these hip replacement kits because they use them. Well, it doesn't turn out always to be the case. And certainly with consumer products, you can safely assume that most consumers know absolutely nothing and not be too far off. Although, again, some client companies just assume that, you know, consumers are right in there with them, working in the lab. We actually had a brain director. You want to test this statement that you need less foot-pounds of torque to twist off the lid of their jar than the competitors. And, you know, he's saying, you know, only 14 foot-pounds of torque. And he really thought that the consumers that use their product would understand that and it would make a big difference to them. So make sure you're addressing the concerns. Make sure you don't overburden people if you're asking them questions. Make sure you understand really what's on their mind. If you haven't gone out and actually, you know, just sat down and talked to some people who do use the product and, you know, care about it, do it. You know, just go and do it. Spend some time before you launch a big, you know, quantitative survey where you're going to, you know, be asking hundreds of questions. You know, because the reality is, even if you want to make a nice, tidy, neat thing, everybody gets their fingers on it, and you know, you end up having, you know, a lot of different questions that you weren't thinking of asking. Okay, again, understand what's pertinent to people. You know, are you asking about things that matter? Okay, so that I think those are real ground rules. And again, when you do this thing, make sure that the people whose lives are going to be influenced within your organization are actually involved in this whole process. It's really critical. We tend to call them stakeholders in the US. I don't know, do you use that term in the UK, stakeholders?
Stakeholders, yeah.
Yeah, I mean, you know, it's not a great term, but
I think there's one barking in the back of Katie's.
Not me. Mine's at home.
Or is that you, Stephen?
I don't know. It could be. I'm sort of blocked up. I can't tell.
Oh, you're blocked. Okay.
Yeah. So.
Yeah, we call them stakeholders. Yeah.
Yeah.
So in your book, you also you have a lot of bonus material, don't you, where you can actually download and different simulators and stuff. Mm-hmm. Talk us through that.
Okay. Well, the outcome of many of these product or message optimization methods, particularly what we call discrete choice modeling in the book, which is actually an established term. It's not my own term. Discrete choice modeling has been around for many years. It's designed to figure out what people will choose if presented with a marketplace full of choices that vary in different ways. So it could vary in features and prices and being present or absent. So in other words, if you're making printers, or you can offer 5 similar printers of 4 so that everybody can have just the one they want. You know, it's like, you know, you get the model Tim printer, you get the model Katie printer, you know, so you could have even the presence and absence of products could be varied. And the problem is, by the time you get done with this, you have millions of possible scenarios. So you make something that runs in Excel and allows you to vary everything that can be varied in different ways and see the outcomes. So those are what the simulators are. They, in the case of a marketplace, you can set the marketplace to anything that you've tested and off between things that you've tested. So for example, if you have a printer that costs $129.99 that you tested and one that costs $199, and you want to test one that costs $179, you can vary between things that you've tested. So there's actually an infinite number of possibilities, and you can use the simulator to just do what-if scenarios. And it also works, by the way, with certain forms of communication, like print and websites. You can vary the elements that appear in a print ad or a web ad, and see how much that increases the likability or overall appeal of the combination of things that you have. So if and this is a less common application right now, but still a good one. So and again, if you have 6 headlines that you might want to use and 4 sublines, it's already 24 things. And then if you don't know which paragraph to go first, which graphic to use, you end up having thousands of possible permutations, and you can find out which one's the favorite. And then with the simulator, you can also find out how much worse the one the boss wants to use is than the favorite one. So, and we actually had an example in the book where the one the boss wanted was about 30% of 30% as appealing as the best possible combination. So that led to the hard job of how to explain to the boss that he's off by 70%, which is a tough one.
Yeah. And you talk in the book about using Bayesian networks or Bayes nets.
Yes.
And that's the best way to actually do some of the simulations.
Yeah, Bayes nets are phenomenal. They are, for found data, for data that you have not set up experimentally. I haven't figured out how to work them into one of these experimentally designed simulations yet, but I'm sure I'll get to it sometime, maybe. But if you have data that you've just found someplace, like or a survey, these are amazing. They really are. There's no limit to the complexity. I have an example in a paper. I couldn't put it in the book because it was a copyrighted illustration, where they're doing gene research, and there are 25,000 nodes in this network. Nodes are like connection points between variables. So the effects on cancer, progression of cancer, 25,000 of these nodes in the Bayesian network. So they could be as complex as you want. And they also give you remarkable readings, very accurate readings of the effects of changing anything. Everything's connected together. So if you change something, the whole network sort of flexes. It's like, this great interconnected being where everything moves when you move one part of it. So if you get the connections approximately right, all of a sudden you get really great readings of effect because it takes into account all the other variables you have in the network. It also, and a lot of people are familiar with regressions, and regressions have been used forever to make predictive models, and they're very good at spot forecasting, but they're not very good at effects for a whole variety of reasons we don't have time to go into. But the Bayesian networks do give you good readings of effects. They're not affected by adding more variables, and they're also the whole distribution of one variable versus the whole distribution of the other variable. And with regression, the underlying paradigm is a correlation, and a correlation is just a simple measure of how well things fall into a straight line. So it's just one summary measure. With the Bayesian network, let's say you have 20 values in one variable and 10 in the other, it's going to make a table with 200 boxes in 10 by 20, and it's going to look for the pattern of correspondences in that giant table. So, it can pick up any sort of, regular relationship, an S-shaped relationship, a U-shaped relationship. It's going to pick up anything that's regular, and it's going to be able to use it. So really remarkable. It's also there, if you get the right, again, there's different software, there's a lot of different approaches, but if you get the right software, you can have gouts of missing data, just buckets of missing data, and it will still return a great model. I actually came across something recently. A client did I got this at the very end, incredibly stupid questionnaire where they asked people about 4 out of 13 things. They had to rate 4 out of 13 things. They were just picked at random. And so everybody had missing data for 9 out of 13 things that were being rated. And that would completely destroy most multivariate modeling methods that we're familiar with. But the Bayesian network was able to use all the data that was present, and it was able to correctly predict effects at about an 85% accuracy level with all those buckets of missing data. So, very useful, very effective. And, if you want to understand effects, it's just a really tremendous method.
I think that's really important. And also when you think, people have thought about AI in terms of impact on blue collar and manual, what you're outlining there, as well as the impact on some major areas of, for example, medical consulting and barristers and advocates and the legal profession are involved in. And I think that level of complexity and analysis, means that this kind of big data, when it's structured in this way and when it's used in that predictive way, is going to actually be applicable in so many areas at every level of business and in every industry sector. And I think that's the huge opportunity, but also the potential fear that a lot of people have.
Right. And, I think in your book, rather in a webinar of yours, I saw you called it donkey work, doing a lot of donkey work. Well, I think this stuff can actually do a lot of real genius work. Yeah. But it's guided genius work. It's like, again, when I talked about HB analysis, as a human being, I don't think we could ever, approximate what that does. But it doesn't take over for us in defining the problem and analyzing the outcome. It's something that works, for us in the background. Same thing with something that everybody, almost everybody who's worked with data knows about. It's classification trees, where they split the sample up again and again and again and again. Well, to split the sample, you have to do some sort of comparison for all the different ways you can split the sample. If you have 300 variables, like the cruise ship example that I give, where they had 300 demographic and other consumption variables that they could use to winnow people into different buckets. How do you compare all of those? Well, it turns out that comparison is so difficult that it actually requires artificial intelligence. There's so many rules and so many things that you need to know that is artificial intelligence. And that has actually been with us since 1990. It was presented at the 6th IEEE conference on artificial intelligence. And, it's amazing. I mean, you two are lucky you don't have to deal with these problems of comparing lots of groups in data, but I do. And it's horrible. It's horrendous. It's a horrendous thing. When you should start, how do I split this thing where there's, 8 different values? How do I split this thing where there's 1,000 different values? But this does it, and it does it very quickly.
Yeah.
Katie, you got any more questions of Steven?
I was going to finally put Steven on the spot. We're talking a lot here about predictions. Again, trying to keep it broad to finish off. Do you predict that what we're describing here of AI will be enhancing our lives and our world, or do you see it in a kind of more threatening way?
Well, the kind of AI I deal with is an enhancement. Okay, the stuff where you don't ask it to make decisions, it's just there to sort of make suggestions or to work with data or to find patterns in data that we can't possibly see. That's an enhancement. That makes things better for everybody. I think when unless maybe a self-driving car, but if you put it in the driver's seat in other areas of your life, if you start asking a machine to decide for you, then we have no idea what the machine's going to do. And again, anything that you get from a machine is only going to be a simulation of what we as people would decide naturally, because we are such amazingly complex beings. With all this, all this cognition going on, but all these other things that are sort of hidden below in the subterranean level, which is affective and unconscious, subconscious, if you prefer, feeding it. And, that all goes into our decisions. And, we don't always make great decisions, but we haven't managed to wipe ourselves out yet. And, who knows what a machine would do? if you try to simulate that. So I think if it's kept in where it belongs, okay, assisting, suggesting, guiding, saying you might have overlooked this, particularly like in medical research. Did you overlook this? You know, here's an answer to this question that you couldn't possibly solve on your own. Then it's great.
Yeah.
But if we start ceding decisions to machines, I think, you know, there's just a world of trouble. It's very possible.
Fascinating. Yeah, thank you.
Thank you,
Steve.
Steve.
Thank you both.
Thank you very much. Thank you. It's been really interesting. Thank you, Katie, as well. Thank you very much as well for your help. Have a good day. Thank you, Stephen. Thank you, Katie.
See you soon.
Thanks, guys.
Bye for now.